Good afternoon, everyone. I want to welcome you to the course. This course will be the theory and concepts of fast RTA, which is rate transient analysis. I'll start by introducing myself. My name is David Anderson. I am the Vice President of Software Development at FICAT. I oversee the development of all of FICAT software applications. My area of expertise is this particular application, fast RTA. So I'm happy to have you here today to present the theory and concepts of this subject. Over the next few hours, we're going to be discussing several different concepts. Before we get into the details of it, I want to show you just a little bit on the front end about the software and the types of things that we're going to be doing with it. Fast RTA is a program that's really designed around production analysis. So what we're interested in is getting the maximum value out of the production data that we have. Traditionally, this really revolves around production forecasting and determining reserves, but we can also do things like determine hydrocarbons in place, permeability, and skin. What you're looking at on the screen right now is a picture of production gas well, production rate, and flowing pressures. With RTA, we take advantage of not just the traditional production rates, but we also look at flowing pressures as well. This is something that is relatively new in the industry. Traditional decline curves never considered flowing pressures, but with the advent of high-resolution data acquisition systems, we're finding this data is more prevalent, easier and cheaper to obtain, and there's a lot of useful information we can get out of it. So the software is really centered around maximizing the value that we can get out of this sort of data. The way the program is set up is we have a number of different tabs, pages, and as we flip through the different pages, we can see there's different methodologies for looking at data. The philosophy with RTA is there isn't one single method that always works. So what we're going to do is look at a whole series of different production analysis methods and compare the results, and hopefully once we've looked at all these different methods, we'll have something that makes sense. It's a very simple philosophy, and it makes a lot of sense because production data analysis is subjective. And we want to be able to have access to all these different methods. And the methods are focused on different things. So for example, traditional decline analysis is focused just on production rates and is useful in situations where we don't know the flowing pressure and maybe don't know a great deal of information about the well, such as if we're analyzing non-op wells for A&D purposes or trying to determine some reserves for wells very quickly. When we get into the more advanced methods, we start to look at type curve interpretations. And we're looking at more detailed information and trying to extract more analytical stuff out of the data. Running all this together and comparing it can get a very reliable interpretation of the data. One of the advantages of doing something like RTA is that the data is being collected and it doesn't cost you anything extra. When we compare this, for example, to a planned pressure transient analysis, like a flow and buildup test, it makes a lot of economic sense to do rate transient analysis. The data is free. It's being collected as a matter of good production practice. We should analyze it and get as much value out of it as we can. So it makes very good practical sense in the absence of a well test to do this sort of work. So what we're going to be talking about over the next few hours or so is we're going to discuss some of the theory and concepts that goes into a philosophy such as rate transient analysis. And the purpose is to help you understand what the concepts are behind the methodologies. A lot of these methods are very easy to apply, but if we don't understand the concepts behind them, they become a little bit dangerous because it turns into a black box and we just, it's very easy to get numbers out of the thing, but we need to know that the numbers are making sense. So the purpose of this course is really for us to understand what the underlying techniques mean and make sure that we're using them correctly and in the right circumstance. Some of the things that I'd like to talk about today is we'll start out with an introduction to well performance analysis, what it really means, what are all the different facets of it, what are the results that we can expect to get out of the data. And then I want to get into ARPS theory. ARPS is, of course, the fellow that invented decline curve analysis way back in the 1940s. We're going to be looking at decline curves and sort of getting a sense for the traditional way of analyzing production data. And more importantly, I want to give you guys a perspective of how we think that fits into the modern concept of decline analysis. We certainly don't want to discard the traditional methods. We still think they're very important, and in fact, they're complementary to a lot of the modern techniques that we have. From there, I want to get into analytical solutions. So we want to talk a little bit about transient versus boundary-dominated flow, and we'll discuss how important that is to understanding truly what your reservoir is trying to tell you. And this has a real practical impact on your day-to-day operations, as we'll see when we start to look at the equations and understand what's going on. We'll talk about type curves, superposition, and analyzing gas reservoirs. Once we get through sort of the theory part, I'd like to put a different twist on it and get into more practical applications. I mean, we're all here because we want to understand how we can apply this technology to real production data. So part of that is understanding the theory, but the more major part of that is understanding how we can actually apply this to our data. So we're going to look at how RTA can be applied practically to real production data. Some of the things we want to look at in terms of methodologies is we want to see Fetkovich type curves, Blassingame type curves, Aggarwal-Gardner, transient, Wattenberger. There's a whole series of different type curve methods. We're going to look at the flowing material balance, which is an integral part of rate transient analysis. And we're going to look at specialized modeling and history matching. And then to sort of wrap things up, we'll talk about practical diagnostics. The sorts of things that you as an engineer working in your data can pick up as just looking at the production data qualitatively. You can end up saving yourself a lot of time and can also end up ensuring that you make the proper decisions regarding what to do with a certain well. So these are very critical things. And it takes some experience to get to the point where you can apply these diagnostics well. But what I hope to do is give you a template that you can start to use to apply these things. We'll start off with an introduction to well performance analysis. Really, well performance analysis is any sort of production flowing pressure data, any data that comes out of the wellhead that we can take and analyze on a time basis. Okay? So we're really interested in gathering as much value out of that data as we can. Beyond that, there's really no there's no mandate beyond that. Whatever data we have, we want to extract as much value as we can. So what are the sorts of things we can get out of production data? Well, I think we're all familiar with production forecasting, deliverability forecasting, and reserves. Those are really the primary things. So that's really one of the fundamentals of rate transient analysis as well. We want to get production forecast and reserves. But beyond that, there's a lot more that we can get as well. We can determine drainage areas. We can determine drainage shapes. We can determine production optimization candidates. We can determine the permeability. We can determine whether or not a fracture treatment has been successful. We can determine whether a well is damaged. So there's a whole nother level of parameters and results that we can get out of the data if we just know where to look. So we're going to focus on some of those things. I want to split production or well performance analysis into two parts. And one of those parts is traditional. Traditional production data analysis, I think, is fairly well known in the industry. We use the ARPS decline curves. Those are really the cornerstone of reserves evaluation and production forecasting. Probably most of you are using these sorts of decline curves every day in your job. So let's talk a little bit about that. Okay, so we've got production rate only. We're using historical trends to predict the future. So traditional decline curves really depend on the historical conditions being maintained through to the future. It's empirical, and really what we're saying there is that there's no theory behind it. Traditional decline curves are really based on analogy. They're based on we're seeing the way a well performs, and therefore we're going to basically just forecast that or forecast other wells that look similar to that in the same manner. The outputs of something like this are going to be, again, production forecast, recoverable reserves under current conditions. These are very important things to know. And one of the advantages of traditional techniques is they can get a handle on these deliverables very quickly. And without a lot of extra, effort and work, we can get these numbers fairly rapidly. But there can be some shortfalls to doing this, and we'll get into that later on. The modern methods is sort of the other side of production analysis. This has really started to become important in the last 10 years or so. Prior to that, these methodologies did exist, but they weren't really all that practical. And one of the reasons is because nobody was collecting flowing pressure data and making it accessible to the engineer in the office until relatively recently. Now that we have access to that data on a very large scale and convenience, the modern methods have become very attractive. And many of the E&P companies in the industry and reserve evaluation companies are using these techniques to analyze wells and get that much more information out of it. The modern methods are based on physics. They're not empirical. They use analytical models to extract information. So we want to actually understand the physics of the fluid flow in the reservoir. This may sound familiar to some of you. It's not a new concept at all. In fact, pressure transient analysis has been doing this for many years. So rate transient analysis really, conceptually, is not all that different from pressure transient analysis. It's just that we're using it in a different way. In a practical sense, we're using it for the long-term production data and making the techniques available to people like reserve evaluators and other folks that want to understand the performance of the well on the long term, rather than just a small group that are going to do initial flow and build-up tests on wells. So you really get a better long-term understanding of the production performance of the well. I like to use the term reservoir signal extraction and characterization. This is something that I really look at production analysis as being. Production analysis is a whole bunch of data, and we really had no control over how that data was collected, the operations and so forth that have gone on to get that data to where it is now. It's really a passive monitoring system. Okay? So we go in and we look at that data, and really what we're doing is a forensic analysis on that data. So we're looking at this data and trying to understand, is there a reservoir signal in there that we can extract somehow? The same thing is sort of true for pressure transient analysis, but in pressure transient tests, we usually have a great deal more control over how the data were collected. When we do a pressure transient test, we design the test to follow a certain path. So we control how the rates were, what rate the well was flowing at, what the bottom hole pressure is going to be, how long we shut the well in. And so the quality of the data is often better than production performance data. Production data is sort of, it's at the mercy of many different systems interacting together. And again, it makes the analyst's job a little more challenging because we have to extract that reservoir signal and try and piece together the operating conditions that came together to make that signal come into being. So there's a lot of work involved just in trying to understand the data itself, which we'll spend some time talking about later on. The deliverables for modern methods are really somewhat the same as traditional methods, but with a little bit of extra. Okay? One of the extra things that we can get is original gas in place and original oil in place. In the traditional methods, we can only get recoverable reserves or expected ultimate recoverables. It's very valuable to have methods that can give you both of these things. In the past, you could really only understand original gas in place or original oil in place volume with, say, something like volumetrics. And that's not a performance-based technique. So you're guessing a lot of times in terms of the areal extent of that reservoir. Well, with production performance analysis, we're getting the volumes in place based on the performance data. So now we have a performance-based recovery factor. We can use this to analyze lots of wells and determine which ones have low recovery factor and therefore which ones require a reservoir engineer's attention or possibly production optimization. So it's a very good tool for screening. I think that occurs further down here, production optimization screening. Okay, so we use RTA to do that sort of thing. We can help define drainage area and shape in much the same sense that we do detect drainage area and possibly the presence of boundaries with pressure transient testing. We can do this with production analysis as well. In fact, we can do a better job of it with production analysis because it's long-term data. We're seeing a long ways into the reservoir, which is a big advantage of production data over well test data. We're seeing much further into the reservoir. We can also identify things like infill potential. If we see that a well is not draining its full drainage spacing, or the spacing density that the well has been drilled on, it may be draining a much smaller volume or area. So therefore, we'd want to go and drill some more wells. So there's a whole host more deliverables available if we go that extra step and apply the modern techniques. The recommended approach that I'm going to be talking about today and going into the theory of all these things is to use both of these techniques together. So conceptually, we want to look at both of these techniques, how they fit together, how they're complementary to each other, and there's a lot we can learn when we do that. Production, I think I mentioned this before, production data analysis should include a comparison of multiple methods. There is no single method that's always going to work 100% of the time. Production data is varied in frequency, quality, duration. These are things that we all know. You want to be able to analyze public data that comes in monthly volumes. Maybe you don't have any flowing pressures available for those. You also want to be able to analyze, minute by minute SCADA data, high frequency, high resolution rates and flowing pressures. These are all different types of data, and we need an approach or a series of different methods that can handle all of these different sorts of data. So the recommended approach is that you can't just do that with one method. It's not a linear approach. We need to look at lots of different methods. And we'll be talking about those different methods. If we can sort of tie everything together, some of these thoughts that I've been mentioning, it's what modern production analysis or rate transient analysis really is. It's an integration of knowledge. In the past, we've sort of had pressure transient people sitting in one camp and production analysts sitting in another camp, and there really hasn't been a whole lot of communication between the two. I really see that changing with modern production analysis because when we start to tie these things together, we get a little bit of the well test side and a little bit of the empirical production analysis side. And when they come together, we can really learn a lot. Okay? So part of production data analysis is marrying the concepts of pressure transient analysis with empirical decline and bringing it together. There's a huge amount of value in doing this because you're bringing a multidiscipline team together as well. In the past, the pressure transient people have really been concerned with early time testing, understanding the near wellbore, determining the reservoir pressure. Over on the other side, the production analysts have been concerned with long-term production forecasting. Well, it turns out that these things are very, very closely related. And the data has really brought them together. And we're learning a lot more about our reservoirs as a result. So this is quite an exciting advancement in the science. Where this really starts to come together nicely is where we have permanent gauges in place that will measure high frequency pressure data. So when there happens to be a plant turnaround or something and the well is shut in, we get a free buildup that we can analyze. When the well is flowing normally, we analyze the drawdown as production analysis. So that really, if you think about it, marries the two concepts of production analysis and pressure transient analysis.